So at this point we know that limits are useful because they allow us to analyze the rate of change of a function at a specific point. We've looked at some strategies to evaluate limits, and here we're going to tackle some less obvious ones. So these are going to be a little bit trickier. Our goal is the same though. So our goal is to still rewrite them so that we can plug in our limit and evaluate using substitute. So notice here we have 12, and then in the denominator, 12 minus 12 would be 0. So I can't directly plug that one in. We want to rewrite that so that x minus 12 is no longer on the bottom. Okay. So the way we did that before is by canceling out terms, factoring sometimes, and then canceling out factors. Here we can't do that. But what we can do is combine our fractions. So I'm not doing anything to the denominator. That's staying the same. But on top, okay, so notice I multiplied each fraction by a version of 1. So 12 over 12 is 1, x over x is 1. And I picked those numbers because look what it gets me on the bottom. I have x and 12 and x and 12. So what I've done is I found a common denominator. And remember, when you multiply fractions, you just multiply straight across. 1 times x is x. Okay, so now I have a common denominator, and I can add my fractions. I can combine them. So when you add fractions, the denominator stays the same and you add the numerator. So what that looks like in this case is I get 12 minus x on top, 12x in that denominator, and then I still haven't changed that x minus 12 on the bottom. Okay, now we're super close. So we have 12 minus x, x minus. So we want those to be the same because then we can cancel those out. Well, notice how the signs are just opposite, right? So positive 12, negative x, positive x. I can be very clever here. I can factor out a negative 1. So notice if I distributed that negative, I would get 12 minus x. 12x I haven't changed. X minus 12 I haven't changed. Okay, now we should be very pleased with ourselves because these can cancel. We're left with the limit as x goes to 12 of negative 1 over 12x. And now notice when I plug in that 12, I can evaluate that. So that negative 1 over 12 times 12, which is 144. Okay. So notice our goal is still the same. We still kept going until we got just plain old 12x in the bottom, and we no longer had that x minus 12 that was preventing us from evaluating the limit. The way we did this, in this case, we combined fractions. So we got a common denominator, and then we added the numerators, kept the denominator the same. So that's what we did in this step, right? And then from there, the other move we made here, and this is a hard move to recognize sometimes, right? We factored out a negative 1 to make our signs the same. Okay, so that was here, right? We pulled out that negative 1. Okay. Our goal is the same. We're just tackling problems that have more complicated steps to get there. Now is a great time to pause and make sure that you have this example captured accurately. The algebra and the steps and the notation here is very important. So make sure you copy these very carefully. Okay, and then our next example, we're going to do this one a little bit differently. So I'm going to show all the steps first, and then I'm going to talk through them. So once I pull those up, I want you to copy down the work so you can just follow along and listen and think about whether or not you're following the steps or not. All right, so take a minute to very carefully copy down these steps, and then I will talk through them and annotate them. I want you to copy it down first, though, so you're not burning any brain power on writing. You can just listen and follow the algebra. Okay, pause if you need more time. So my first move was to get a common denominator. Okay, so notice I multiplied the fractions by same thing on top and bottom for both. And I multiplied by the denominator of the opposite fraction. So what that gets me, like on the bottom, is a denominator that's the same for both. So I did that because I wanted to add them, right? And then notice also when I multiply this 1 through in the numerator, nothing changes, right? So I can just drop that 1, and that brings me to my next step here. Now, I want to combine these two fractions, so notice I have a common denominator for both because of the move I made in the last step. And I'm subtracting them. So for my second fraction, I'm going to go ahead and distribute that negative through. And that gets me this minus 3 minus x. My denominator and then my overall denominator stays the same. So remember, I want to be able to plug in 0. So as long as I have this x on the bottom, I'm not done yet, right? So I'm going to keep going. I'm going to notice plus 3 minus 3 cancels out. And then negative x, well, that's negative 2x here. Everything else stays the same. And now, x. And I should be happy about that because that was what was keeping me from evaluating, right? So now I have negative 2 over 3 plus x, 3 minus x. I'm going to plug in my 0 now. So 3 times 3 on the bottom is 9. Okay, so the most common mistake I see algebraically when people solve these is getting this common denominator. So we're going to make this note. So whatever I do to the numerator, typo here, I must also do to the denominator, right? Just like whatever you do to one side of an equation, you have to do to the other side to keep the two sides equal. It's also true in a way for these fractions, okay? So if I multiply 3 minus x in the bottom, I also have to multiply the numerator by that, and that's to keep the fraction the same. Again, these are just fancy forms of 1 here. So I'm multiplying by 1, and we know that when we multiply by 1, nothing changes. Okay. Here are our steps overall now. So we have 3 strategies we can try for tackling limit. The first is just to try to plug in the limit, and notice we couldn't do that here because we had 0 in the denominator. If that doesn't work, we need to rewrite. So the next step is to look for something that I can cancel. And that's what we ultimately did here, right? We had x and x canceled out. But if we can't do that to begin with, another strategy we can try, and this is the new thing in this lesson, is to combine fractions and cancel. Our goal still is the same. Our goal is to rewrite the limits that you can evaluate by substitution. So no matter how challenging they get, keep that in your mind. Okay, so I divided these notes up into 2 parts. So now go try to practice this a little bit, and then we'll come back and we'll tackle something that's related but a little bit different.